We have 6 people here. Do we want to have like brief introductions before we
Sure.
jump into the slides?
That sounds good. Um, I'm Shannon Appelkline. I'm the technical writer at Blockchain Commons. Did learning from the Bitcoin command line, most of our other stuff that we've written about URs and a lot of our other docs and information to date. Wolf?
Yeah, I'm Wolf McNally. I'm lead researcher for Blockchain Commons. I've been a technologist for over 40 years, and I'm the author of the UR specifications, the Gordian envelope specifications, and obviously I consider those to be a community effort. Even if I'm kind of in the intellectual lead, these are ongoing conversations, and I'm looking forward to moving forward today.
Great.
Cool.
Um,
I can go next.
great.
I'm Ken, the CTO of Foundation Devices. We make a Bitcoin hardware wallet called Passport. And so this is, directly some of the stuff we talk about in these meetings. And also the one particularly, the topic we're here to talk about is of interest to us. I'm a software engineer by trade, mostly C, C++, device drivers, low-level stuff, but then also later, all the way up the stack to GUIs and web development and stuff. So I kind of run the gamut in my history, but that's me in a nutshell.
Seedhammer?
I'm Craig.
Go ahead, Craig.
I
Sorry.
don't. I don't believe Seedhammer. He sent us a chat note just saying that he doesn't have a mic, so I don't think he's going to speak. But I'm Craig. Developed Sparrow Wallet. I think from the small list of people here that I don't need to introduce it. So you guys know what I do. Yeah, happy to crack on.
I do have a microphone. I don't know who
Oh.
the other E is.
Yeah.
So I'm the one that is logged on as E from Seedhammer. I am going to, I hope to make a small presentation today. I'm pretty much the technical guy from the Seedhammer side. Seedhammer is very, very briefly an automatic metal backup solution for Bitcoin wallets. So we produce and sell machines that can engrave, in a secure way, engrave your seed phrases and your the public information for a wallet. In today, that's descriptors in the UR format. So yeah, that's me.
Great. All right. Let's go ahead and get going. I will.
And if the E listening wants to type something about himself, then we'll read it. So
yeah.
But welcome everybody. Go ahead, Shannon.
Definitely. Thanks, Wolf. All right. So we are Blockchain Commons. We've been doing these meetings bi-monthly lately. And this is our usual spiel about what we do. We're, of course, interested in self-sovereign control of digital assets. And this year, our main focus through that has been on Gordian envelope and on collaborative seed recovery. Our goal is to give people choice in how to control their digital assets. And we definitely want to say thank you to our sponsors. We would not be able to do anything if we did not have sponsorship, since we are a not-for-profit organization. So thank you very much.
We also encourage everybody who's listening to this to become a sponsor, which you can do, obviously, at the link there.
Definitely. So September was our last meeting. It was a pretty big meeting because we talked about the results of IETF 117, where we were able to push forward on DC Bor, and also we really figured out what numbers we were going to be able to get registered from IANA for our CBOR tags. And that had some big results on Gordian envelope, and it also had big results on our older UR specs, which are exactly what we're going to be talking about today. Also at September, we talked about attachments, which are a new methodology for envelope, so that individual companies can stick their proprietary or their own specified information into envelopes. We talked about our developer web pages, which are now all at developer.blockchaincommons.com. It has everything, or most everything, that we've written to date. So we encourage you to take a look at that. We talked about some formatting for disclosing under YAML, and also that our Rust libraries are in community review, and we're going to be expanding on that because we've done some building with them ourselves. So that was last time around. Hey, Hank, glad to see you. We're just getting started. Okay, today's topics.
Hi.
Go ahead, Hank. You can introduce yourself briefly if you like before we continue.
Yeah, Hank.
Okay, sorry, I was late. I couldn't do anything about it. It's Hank here. I live in Portugal, originally from the Netherlands. I work a lot on Carry and HTTC and that kind of stuff. Caesar as well, and I think that's enough connections to the topic here at Blockchain Commons. Thank you.
Great to see you, Hank. Okay, so today's topics. We're going to start out with a discussion of output descriptors, which we have a couple of different things running around on. And then Wolf's going to show us how the new Rust-based envelope CLI looks. He's going to give us a preview of what we're going to be doing with our first TSR server, which we think we're probably calling depository. And we're going to talk about some of our future looking that we've done in some of the musings that Christopher's been writing lately. So onward. Okay, output descriptors. We clearly need an interoperable way to store descriptors. They're the future of walled interoperability. It gives us a way to not just store the keys, but also the scripts, the derivation paths, so that we can go back, 5 years later, 10 years later, or just when we're exchanging it with another wallet and actually retrieve where our addresses are. Unfortunately, given the need to make something interoperable, we actually have 3 different things that we're looking at today, and we're going to get to each of these in turn. So just to briefly talk about them, we had our original proposal, but we put out in 2020, which was a UR format for crypto output that basically said, how do we take a descriptor and put it into a binary farm that works well with CBOR? And Craig expanded that, I believe, with the account, which puts together a bunch of outputs, as I recall.
Yes.
For various reasons, which we'll get to momentarily, we've had to back off of that, and we're going to talk about what the best way to actually do that is. But our current proposal is a Gordian envelope with the descriptors, but also with metadata. And Seedhammer also has a proposal, which is a PSBT-based one, using some of the formatting for PSBTs right now to instead store descriptors. So let's just jump into each of those. So our original proposal, Wolf, you want to jump in and talk about what was going on here?
Yeah, feel free to jump in and fill in any gaps anywhere you see any, Shannon. So our original idea was to base a big part our stack when it came to both static data at rest as well as data in transit on CBOR. And CBOR, we've basically defended our choice in a number of different ways. There's videos and papers and so on. You can go to read on why, so I'm not going to dwell on that. But if you're not familiar with CBOR, think of it as like JSON, but for binary. In addition to that, we've advanced an IETF internet draft, which is called DCBOR or deterministic CBOR, which is a set of rules on top of CBOR, which limits the way certain things can be encoded. That basically incorporates some suggestions that the community was already dealing with, but adds on top of that additional things that we felt were gaps when it comes to determinism. And determinism is obviously more important when you care about high security or various kinds of participants converging on a single binary sequence for a set of data, even if they're encoding it separately. So because if you want to assign hashes or check hashes and you want to have various parties doing these things, then having a deterministic encoding method is important. And DCBOR bakes in at the roots as opposed to tries to add on top, like proposals like JSON canonicalization and so on. So part of our adoption of CBOR involved our working with the CBOR spec as it stands. One of the great things about CBOR is if you design structures right, they're self-describing. And this is often done through what's called CBOR tags. CBOR tags are numerical identifiers. There's quite a large numeric space, but the lower numbers require fewer bytes. Under 23, it's 1 byte. 24 and above, it's 2 bytes, and then each time you double. So 3 bytes with the header plus a 2 byte length gives you a 4 byte. Gives you 65,535, and then so on, doubles to 4 bytes and then 8 bytes. So you can have a very large space. It just depends on how many bytes you want to spend. And part of our goals was to make Gordian envelope, or not Gordian envelope, but all the CBOR stuff we did compact and not waste resources unnecessarily in terms of bytes on the wire or bytes at rest. So we embraced the idea of IANA numbers. And if anybody's interested, I'm going to paste into the, I'm not going to take over the screen share at the moment, but I'm going to paste the IANA registry of CBOR tags. So you can refer to that. That's in the chat now, if you wish to refer to that. And when we first read this, not having, Christopher has worked on ETF proposals before. He worked on versions of SSL TLS, I believe. But as you can see, if you go to the top of this, and I'll just describe it, you don't need to see this, but if you're looking at it, then you'll see what I'm talking about. It gives ranges of CBOR tag numbers and the registration procedures. And for 0 to 23, it's a standards action, which basically means unless you finally get an RFC, you're never going to get into that range. And RFC is a finalized standard in the IETF. And 24 through 32767 says specification required. And if you look to the list below, a lot of these specs are not RFCs. That's great, but they occupy these higher numbers in this range. And so we presumed incorrectly, as it turns out, that that numbers in that range, we could publish a spec and then ask IANA to register it, and they'd say, oh yes, there's a spec for this, and this is a previously unoccupied code point, so it's granted. And then above that is 32768 to the maximum you can have for 8 bytes, very large number, which it says first come, first serve. And that basically means, if you take one of those positions and you basically tell them, I'm registering this for this, they'll say, okay. And it turns out that's true. Okay. The problem is with the middle range specification required, because it's not just that you publish specification is required, but it has to be reviewed by IANA experts, which in this case turn out to be the currently appointed IANA experts are some of the leaders in the CBOR working group in IETF. And so we were basically advancing 2 proposals to the CBOR working group. Specifically, the main proposal we're advancing to the CBOR working group is our specification for DCBOR. And there's been a lot of conversation in that working group about that. A lot of very supportive, some of it critical, but we took it to heart. So we've basically improved the proposal due to that. And we believe that it does have a chance of becoming an RFC eventually, depending on adoption and interest. And then on top of that, we advanced our proposal for Gordian envelope, which requires DCBOR. And to do that, the initial specification for Gordian envelope allocated a number of CBOR tags from the range 24 through 32767. And it also, because we had been working with this for a while, a number of our other proposals, including the ones that we're going to be talking about for output descriptors and some of the proposals they're built on, also allocated tags. So if you look at our reference code, we have quite a few tags in the 300 range, 400 range, 500 range that are not used in this registry, that we just said, okay, we're going to use that when the time comes. We'll just publish a spec, and IANA will say yes. Well, what we learned when we delivered our Gordian envelope spec to IANA is they passed it back to the same people we've been talking about at DCBOR in the CBOR working group, and they said, why do you want all these tags? These are low numbers. This is valuable real estate because these only take 2 to 3 bytes to encode, and there's only, and Karsten Borman, one of the main people who was one of the developers of CBOR originally, basically said, we can only allocate so many of these per year in order to have the life cycle that we want for CBOR. And so he pushed back on that pretty hard. And we took that to heart. That was particularly one of the things we talked about at IETF 117 in San Francisco. So we came back after kind of understanding their needs much better. And I actually went back to work on the Gordian envelope spec and reworked it. So it ended up only needing 1 tag, which we proposed would be the tag 200. And we, so we basically took that and reworked proposal. And as a matter of fact, the Gordian envelope proposal became much more tight much more, because rather than using this series of tags we had proposed, we basically started using the structure of CBOR itself. So, for example, a CBOR map can have any number of key value pairs, but we specifically use maps for assertions. So, predicate object becomes a map with exactly two elements, never more, in it. And the subject followed by its assertions is an array. And because it's an array, the first element being the subject of the envelope, and then the elements after it being the predicate object pairs of the assertions of the envelope, it turns out we didn't need tags because we could basically use the structure of a valid CBOR object as the actual structure of the envelope. And so we basically eliminated the need for all the other tags. Now, do we eliminate the need for all tags forever? No, because the leaf of an envelope can be, first of all, it's tag 24. 24 is an existing low number tag, meaning this is embedded CBOR. So we're using that for our leaves. That's how you know you've reached a leaf of a Gordian envelope. Meanwhile, above that, we can use anything in leaf. So you can have a 24 tagged something else entirely, and we do that as well. But we realized that the tags in the 300, 400, 500 range that we've been using and promulgating in our BCRs for this are in the range that IANA and their experts, which are the leaders of the CBOR working group, are going to push back on hard. And that brought us up short. So we realized that because inherently there's nothing wrong with the UR output descriptor as we defined it. It's a compact CBOR structure. And it basically uses a number of tags that aren't likely going to be available to us unless we, basically wage political campaigns that probably none of us want to do. If there's one potential solution is we can move to much higher tags. We can move into the first come first serve range, which tend to be in the higher 3 byte to 5 and 9 bytes, and they're just going to grant those. So that's one choice we could make, but it's a breaking change, and that's something that we as a community need to consider. But because of this, we realized, okay, well, moving forward, we need another solution. And because we've been developing Gordian envelope, we realized that envelope would be a great extensible way of containing things like output descriptors and all kinds of other things, because you can do signing, elision, compression, things like that with envelopes, and so they're extremely flexible. And so we started developing a series of proposals based on how to structure envelopes for specific purposes. So we developed a set of proposals for that, and including an output descriptor. And we decided for this, rather than go into the detail we did with our UR output descriptor, we would adopt the textual format that is pretty much now standard in the Bitcoin world for conveying output descriptors, because there's already a lot of code that exists to parse that, and also because it's a moving target. So because output descriptors are not like an official finalized standard, they're not crystallized, there's no official version 1, because certain things are moving forward. We realized that rather than try to track that ourselves, it would be better if we rely on existing code to parse and output descriptors, rather than make a separate parallel thing that had to capture all that nuance. And so our way of representing output descriptors, which I presume several of you have seen, but I'll show a slide of it later, is basically very simple, allows a certain amount of metadata attached to it, and is also very minimal. So when we did this, we go back one slide. Yeah, we'll come to that. Go back one slide. One more.
You wanted, I think, the new envelope format.
Yeah, I actually want to go back a couple more, because there's a point I wanted to make on a previous slide. One more. Great. So basically, because we realized that there's no chance of getting IANA recognition for the tags we wanted, we marked the existing proposals of 2010 and 2015, or actually what we're calling, what we've always called research papers, as deprecated. And this is, the slide said, this doesn't mean that we superseded it, doesn't mean you can't use it, doesn't mean, but we realized that it has certain shortcongings, in this case with the standards bodies. And we'd like what we produce. We don't consider ourselves to be a standards organization, but we do consider ourselves to be an organization that works with standards organizations. And so basically you can squat on CBOR tags. It's not looked upon favorably. You're not likely to get anything ever moved forward to an RFC unless unless, for example, it reaches such major adoption they kind of have to give it to you, and they don't like doing that, or unless you basically make a very strong case that you need those tags for a specific good purpose. So we were able to get, if you look back at that registry I post, you'll see tag 200 is now Gordian envelope. They went after seeing our revised Gordian envelope spec, they granted us tag 200, yay. And so now whenever you see a CBOR tag 200, you know it's a Gordian envelope. And we'll see an example of how that matters a little bit later. But so we mark these as deprecated, and this rubs some feathers the wrong way. We understand that now. We did not mean to say that these things are useless or that you shouldn't use them. We would prefer to have a conversation going forward about the best way forward. We can continue as a community to squat on these tags and use these. We can deprecate, if we chose to do that, then we could deprecate the Gordian envelope version of output descriptor. I'm fine with that too, if that's a decision that we're ready to undertake, because, or we could move to a higher number of tags that break backwards compatibility. So that we have a number of options for us. Then Seedhammer also has his proposal, which is, or I should say, from Seedhammer has his proposal, which is a completely separate format, which we've discussed some on GitHub, and I'm sure we'll talk about that too. So, we are working with the community as part of a learning process. Again, we, other than Christopher's work with the IETF some time back with SLTLS, I have no experience working with these standards bodies. So this is a learning experience for me. And so, we're basically trying to being an essential place for conversation. And BCRs have always been about conversation. They've been conversation backed by running code. But and we'll talk about this a little bit more, but we've always basically said that, look, these aren't final standards, these aren't approved by any standards body. If you use them, you're using them at your own risk. They're for community review. And and so we really appreciate that people have given us the enthusiasm they have. But this is something where we feel like we're all learning how to work together here, and we want to work together for everybody's benefit. So, and the last point on there, we're small. We need resources. It's basically, Christopher, Shannon, and myself. Obviously, there's many kinds of resources. There's contributions in code. There's writing more BCRs. There's the conversations like we've been having, and there's sponsorship. So, we appreciate all of those things, and we think that we can move these things, the best of what we do, towards standards, and work with standards bodies. Okay, next slide.
Yeah, hold on. Before we go there, one of the things that we learned during this process is we need to better track who is using which of our proposals, because we need to be able to move proposals to a different state. And so that's going to be what the next slide is. That in this case, we now better know, and we kind of knew before because I've used the output in account descriptors on Sparrow, but that Sparrow uses some of these, and that's one of the problems that we had here. And so we need to better track that so that we can take a slightly different direction when we have something that is in more wide applicability. So we're going to talk about that. But Craig, I wondered if you could maybe respond to some of what Wolf said. We've offered a couple different options. We could just squat on these tags. We could move them to higher numbers. We could push more heavily for people to use the envelope methodology, our Seedhammers for that matter. We could talk about if the word deprecated is the right one, or something else for something that we're no longer pushing. Do you have ideas for what would work for you and that would make sure that things that are currently stored as crypto outputs aren't going to get lost at some time in the future?
Yeah, thanks. So, I've been giving this some thought since last week, and I think, fundamentally we have slightly different goals. You are obviously working towards sort of a long-term standards approach, in the sense that you understand a standard to be defined by one of these international bodies. Whereas, as application developers, hardware wallet developers, we have users that we need to service now. So you say that the BCR are research papers and meant to encourage discussion. But of course, if you put something out there for 3 years and people use it, it becomes an adopted standard. And I'm saying standard with air quotes here, because I understand that there are different views on those things. And we could argue that none of the BIPs are, in fact, standards. You could even say that something called a request for comments doesn't sound much like a standard to me, but clearly in the eyes of certain people it is, right? So
well,
I think
it actually has moved, they've moved the official definition of RFC to mean a standard now. It no longer stands for request for comments. And Bitcoin improvement proposals, or BIPs, they're pretty much at this point. I don't know what the process is of getting a BIP published, but I think it's probably further along than we consider our BCRs. But please continue.
Yeah, I mean, to be honest, I have gone through the process of getting a bit published, and it's really, it's actually not super hard. I guess the point that I'm trying to make here is not to encourage debate on what is a standard or not. I'm just trying to make the point that when something gets put out there and gets used, we just don't have a choice anymore. It's simply a black and white thing. We either can support our users going forward or not. And I think we're all on the same page, I hope, as in terms of that. So I don't really have a strong view on what the way forward is. I understand the reasons that you have led you to deprecate the UR types that you have. They make sense. They seem logical engineering reasons. Whether that's going to make sense to users is a different matter, but I do see where you're coming from there. I don't have a strong view on what the path forward is. What I do have a view on is that I am reluctant to change Sparrow to support anything else until I have more certainty. And I think that your BCP, I believe, route forward makes sense, because I don't think we can wait on getting an RFC, which I understand can take years. So, some more certainty, I think, is required. Some more idea that this thing is not going to go away. And once we have that, I think then I can look at it and say, this is something that Sparrow can move to. But what I don't want to do is to have 2 or 3 or 4 of these things. That doesn't sound like a good place to be in. So I'd rather stick with what we have, as you say, squat on those tags for a while until we're clearer on what the path forward is, and then we can, communicate a way forward to users. We can explain to them what the advantages of the new route is. We can reassure them that the old path is not going to be removed, and that's, I think, kind of the best we can do here. I'm certainly not here to accuse anyone. I think everyone's trying to do their best. I just realize that I have a deep responsibility to make sure people don't lose funds, and that's really going to always be my number one concern in terms of building Sparrow. So those are more or less my thoughts on it. And yeah, I'm happy to hear from others.
Yeah, if I may quickly respond, I totally am in alignment with your responsibility to your users, because obviously we all care about the crypto assets we're protecting and how people use that. And a thought occurred to me while you were speaking that because, again, the nature of CBOR is actually really great because it's self-describing. We do have a tag for crypto output. It's in the lower numbered range. It's how we start the tag currently. But what is inside that tag at this point is a defined CBOR structure. That is the tag we defined in our BCR 2010. But that could also be construed as being version 1. Version 2 that can also be inside that tag is an envelope containing the structure that we're developing that we think is more future-proof, better for moving forward. So it's possible without even changing the external tag, by defining that when you open up that tag, you could find a version 1, which is the structures we define it, or a version 2, which is an envelope of the structure we've defined. That basically we can say that systems that care about legacy support versions 1 and 2, preferably write 2 and read 1 and 2. and versions, and applications that have less concern for backwards compatibility could just read and write version 2. I think that would be a way that users could still work with URs that say crypto output and understand what they're for, and have essentially know that what they're using them for is safe, and without any change to the current specification, except an extension that a version 2 has an envelope inside it. And this would allow us to eventually possibly move version 2 towards something that we can actually well, in fact, the envelope doesn't require tags at all, and I'll talk about that more a little bit later. But other than the 200 tag on the outside, the specs we're developing require no interaction with IANA at all, because of our known value system. And I'll describe that a little bit more in detail later. But yeah, so I think there's a way of moving forward here which doesn't compromise backward compatibility, and maybe instead of calling 2010 and 2015 deprecated, maybe better just to relabel them version 1.
I really like that idea, Wolf. That sounds like a great solution to this. It kind of means that those users who have and those developers who've gone ahead and adopted version 1 aren't feeling like they've made a mistake. So it kind of just feels like there's a natural upgrade path. That proposal that you make really sounds worthwhile to me.
Okay.
Right.
So
yeah,
Shannon?
I totally agree that, and I was about to ask the same question basically before you started talking about that. I think like deprecated kind of is the right word too, right? Even if you don't necessarily communicate it to users that way.
There's a lot of connotation to that in calling something 2.0. Who wants to stick with 1.0? If you have choice, you have to.
Yeah. So like it just means like, well, this is still, even like an API, right? Like deprecated API usually still works for some amount of time. It's fine to keep using it. You just have to understand that we've moved on to version 2, and that perhaps at some point in the future, using this format is maybe not going to be so well supported.
That was the connotation we intended. We did not say that this is, nobody can use this anymore, everything's going to break, and so on. Our intention of using the word deprecation was in that sense, Ken.
Right. That's what I thought.
Yeah, our expectation is that we'll be keeping these BCRs around permanently, so that if someone comes in 5 or 10 years from now and says, hey, how does this work so I can get my assets back, they'll still be able to look at the BCR and see what the format is and figure out how to pull it out. So when we say we're deprecating something, we're definitely not erasing it. We want it to be there because resilience is one of our prime responsibilities.
I would also say, like, as far as like the squatting on the tags, like I think it's a pretty minor issue as well, because like you're already in the context of this crypto descriptors and stuff. It's not like you're going to get confused, I think, with some other software that maybe eventually adopts some of the other tags.
The issue there, since everything that's DCBOR is valid CBOR, of how we play within the larger CBOR ecosystem and other tooling and documentation that's intended to support that, like the IANA registry. If somebody looks up 300 and they expect it to be something that's in the IANA registry, and it's either not there or something entirely different, or they use tools that say output CBOR and they get entirely wrong semantics, then that can cause confusion down the road. And I think that's what IANA and the CBOR working group are trying to avoid.
Right. I was just saying, from a practical point of view, of course, if I look it up and it says something different, that's one thing. But if our specification is consistent in itself, I don't think it'll cause any problem.
Yeah, I totally agree that it's internally self-consistent.
Yeah, and I think the issue here is we just really can't go to IANA or IETF anymore with 2010 as something we're presenting to them, at least in its current form. And so that's what deprecated meant to us. That's something we can't push anymore.
IETF has been known to, or and again, we're talking about what the technical chain is. These are the IANA experts who happen to be members of the CBOR working group. But IETF has been known to allow RFCs to be created around things that have just emerged as de facto standards too. Once they've gotten enough adoption, and there's no point in trying to perfect them, they are as they are. They're essentially documenting and solidifying what's already actually out there in use de facto. So that's another route. It's not the preferred one, but it's a possibility.
Okay, so to talk a little bit more about our specification process, I'm glad we were able to get a good answer there. We've always had the BCRs, our research papers, and as Wolf said, they're fluid. They're stuff that, you know, usually are based upon our own coding API, and Wolf then pushes them in as research papers to explain in detail how they work. And just as a side note, which is going to be relevant when we talk to Seedhammer momentarily, we're happy to see external BCRs. If someone wants to present a possible methodology for doing something within the space that we're working in, then yes, please submit a BCR. That's what 2015 from Craig was. Anyway, all of our research papers are in the research repo at Blockchain Commons. But what this whole situation really showed to us is something that we've known for a while, and we just haven't prioritized because of our limited resources, that we need to raise up some of our BCRs to the next level because they are in active use. And our criteria for the next level is, are there at least 2 external parties who are both using the specification? And if so, we are at this point going to push them up to be what we're calling a BCP, Blockchain Commons Proposal. And if you went and looked in the directory, there aren't any right now, though we know there are some that meet the criteria. And
certainly things like the basic Gordian envelope, because it's already an ITF draft, things like that. And you know, certainly I don't know, Craig, if there's other users of crypto account yet. Maybe obviously Gordian C tool doesn't count because it's the iOS app, because even though we output it, you know, we don't consider ourselves to be a qualifying party for usage, because, you know, we're not an independent wallet maker or anything like that. We're you know, we are what we are. You know, once something does become entrenched, and maybe, you know, the idea is to promote BCR 2010 and 15 to 2010 and 2010 and 2015 to BCP status, then, you know, but give them version numbers, you know, that essentially are backwards compatible. You know, then, you know, that's, well, I'll let Shannon continue at this point.
Yeah, so our main goal with this is they might still be fluid because we haven't actually pushed them into a full standardization process. And certainly, as we've learned, going into the full standardization process can force changes on us, often very good changes, but they can force that. But when something's a BCP, we're going to try and do less of that. We're not just going to change it on our whim. Not that this was on our whim, but some of the BCRs certainly are. And more importantly, we're going to know who's working on it, and we're going to talk to them when we're making changes. So if something like this came up in the future, we'd expect to be able to have that conversation, say in this case with Craig, beforehand about the best way to push forward on this. So
and probably our this has occurred to me, Shannon, that our BCPs should probably have a paragraph near the top of section explaining our rationale for promoting it to a BCP, like who's using it, or, you know, how far along it is in the standards process, things like that, that basically, you know, give us our motivation for elevating it.
Yeah, that sounds terrific. We have the criteria for what it is, but putting that into the actual BCP would help us track things. So this is our intent going forward, to try and make sure that in a situation like this where there are changes that are required, we know who the other stakeholders are and can move forward with them together in a more coherent, collaborative way.
Seedhammer says, and Ken confirms in chat, that Seed Signer uses crypto account, so that's 2 parties, and you know, so yeah, and of course crypto account uses crypto output.
Yeah. So did anyone have any thoughts on our work here? Okay.
I just wanted to add the thought that if we are deprecating crypto output and moving to a replacement, we should consider the same for crypto account. What is the replacement? You know, that seems important.
Absolutely, and it just like it wasn't hard to define crypto account once crypto output was written. I don't think it will be very hard at all to do a crypto account 2.0, which is essentially a bundle of crypto output 2.0s.
Yeah. Okay, so
Okay, great.
we should definitely get that on our to-do too. And it's great to hear that it's being used by multiple parties.
Mhm.
Okay, so this, which Wolf already alluded to, is what our current proposal is for an envelope-based output descriptor. As he said, it just includes the text and has some has a flag of his output descriptor and has some metadata.
Now, just briefly for people who aren't too familiar with envelopes, the actual output descriptor begins with the quote and in the contents inside WPKH. So the actual output descriptor is the subject of the envelope. And again, you'll have to go back to understand what subject, predicate, and objects are, what subjects and assertions are. But Shannon, if you scroll all the way to the right in that little pane there, you'll see that on the at the very end is an open bracket. And that, go ahead and scroll back to the left. And that open bracket is mated by the one directly underneath output descriptor. Yes, that one. So that is itself, that is the conformant output descriptor, which is basically the subject, which is the string beginning WPKH, and 3 assertions: is an output descriptor, has name example, and note. This is the note. And the items without quotes here is a output descriptor, has name, note, are what's called known values, which basically means they're not represented as strings in a Gordian envelope. They're represented as numeric values in a namespace we define. Is a known value 1 because it's basically being used in all respects for as a type descriptor. And then this basically kind of follows kind of the semantics that, or at least it is meant to follow the semantics in the kind of larger kind of ontology definition community for various kinds of smart documents. But in this case, it declares its type and then has 2 pieces of metadata. And this is essentially what all envelopes look like. They have a subject and 0 or more assertions. This is then contained, this output descriptor is then the object of an assertion. The predicate of the assertion is output descriptor, the lowercase output descriptor, colon, and then the object of the assertion is the output descriptor itself, which is everything I just described. And this is and together, this is the one assertion on the string example. So as you can see, it's very recursive, and I've talked about it in other videos and so on. So you can, and this is all a very compact CBOR structure, and we'll talk about that a little bit more. All I can say is once you dip your toe in, you'll realize it's not as intimidating as it looks, and it's much nicer than JSON to work with. Since I worked with extensively JSON, now obviously, okay, I'm biased. I developed envelope, but it's actually really easy to work with. And so and has some really strong benefits to it that we've designed it from scratch. So go ahead, Shannon.
Yeah, so that's basically our new format. It uses envelope. It's built on CBOR. And that's what our proposal is for moving forward. And I think possibly based on what we talked about here, we may also incorporate this as a V2 of 2020-10. If you want to read the full spec, it's at that tiny URL, Gordian-descriptors. That's just a pointer to our BCR that describes this new format. But there's not much more than this. It's a very simple description because things are simple to describe in envelope. All right, so I think at this point, I'm going to turn over to Seedhammer because Seedhammer said, hey, I have some concerns about CBOR and wanted to offer a different proposal. So let me get out of sharing. And if you want to jump in, E from Seedhammer.
Thanks. So I have a very short, I hope everyone can see my screen.
We can see.
I have a short, very short presentation because I think we all know the basic technical differences and issues, and also to leave some time for comments and so on. So what I have, or we have from Seedhammer, is an alternative format. It's described in the, I'll share the link momentarily. It's an alternative format based on the PSPT, which is the format, the binary format, serialization format you use for partially signed Bitcoin transactions. First and foremost, I'd like to share that I am very biased because I come from Seed Hammer, which is a Bitcoin-only company, and as such, these I will make some claims and some comparison and some value judgments that is from the perspective of Bitcoin. So in the larger perspective, I don't have much. I don't have much comments on the envelope format itself. I mostly have an issue with using envelopes for Bitcoin output descriptors. Being from Seed Hammer, where we want to engrave these descriptors or wallets or whatever you call them into metal, we'd like to achieve compact encoding size, but also a very simple, as simple a specification as possible, because we'd like to in the future be able to do all these things from a microcontroller, which has limited size, available space for both memory, of course, but also for the amount of code you can include in Flash. So the problem, as I see it, or we see it, is that there is currently no widespread standard for exchanging wallet setups. There is the Blue Wallet format. I'm sure that everyone is familiar with that. It's textual, but it's also inflexible because it's pretty much made for what they call vaults, which is n of an M of n multi-sig setups. So they have their format is very targeted to that. They have a policy separate from the keys, and they have some metadata, which is a good thing, but they are not really, that standard is not really extensible to generic output descriptors. I also think that the format predates output descriptors, so it's there's good reason for this, but it also means that where I believe that the Blue Wallet format is probably the most widespread, it's also the one that is least useful. So the next one is the one we've discussed earlier today. It's the BCR 2020-10 crypto output. It's deprecated, which is one thing, but as Craig and Wolf said, it's not like it's going anywhere. The problem with that is both the IANA, the standardization problem, which, as Ken says, is not as big a problem for us. The biggest problem is it's inflexible in the sense that every time the output descriptor format adds a feature, you will have to describe that in CBOR or in BCR or whatever you call it. You will have to have a mirror description or specification for that feature in binary. Whereas both our proposal and the envelope proposal for output descriptors simply uses the textual description. I'm not even sure what the bib is. It's a bib, and the Bitcoin Core and all many other wallets implemented. It's a textual representation of the output description. And that's not as compact as a binary representation, but it is very simple in the sense that you don't need to update the encoding specification every time every time the output descriptor specification changes. There's a small
one point of minor clarification I would just want to make quickly is BCR 2020-10-15 are based on CBOR as well, even though you don't explicitly state it there. It's, you say envelopes based on CBOR. All of our specifications for data storage now are now based on CBOR. Yes. So that's just a point of clarification.
Yes, and being based on CBOR as the binary format is very compact, which is what we love. So BCR 2020-10 is perfect for our metal plates because you can get very far with not that much space. So they're both of the blockchain commons formats are based on CBOR, whereas this proposal is based on PSPT. So the technical differences are primarily, I'll get to that in the next slide. The technical differences is primarily between the encoding, the underlying structure of the encoding, where there's the CBOR versus PSPT. The only other difference is that the metadata wise, we want to follow or try to follow the wallet policy bib, which extracts or separates the keys from the descriptor. So the descriptor, instead of having the XPubs or whatever embedded in the text, you extract them to a separate structure, which makes the advantage that you can refer to them several times from the descriptor, and also you can compactly encode them, because there is a compact binary representation also from PSPT of an XPub that takes quite a lot less space than the typical textual XPub representation. But again, that's not a big difference because that can also be added to the blockchain commons format in CBOR. So the biggest difference I see is CBOR versus PSPT. CBOR is a more complex specification than PSPT. I don't think that is controversial. The controversy is about, is it worth it? Is the more complex specification, which is a CBOR and envelopes on top, is that worth what we gain from it? The PSPT is also standard, or at least again from my biased viewpoint of coming from the Bitcoin community, is, I would say, just as much a standard, if not more a standard, because it has a BIP backing it. Which at least it's the sense. It's not a necessarily a fact, but I have the sense that BIBs are more respected, or at least more seen as appropriate to Bitcoin than the IETF. And again, I could be wrong there, but that's one of my claims at least. And again, PSPT is already required for every signing device, in the sense that if you have a signing device at all, hardware, wallet device, software such as Sparrow, you need to support PSPT anyway, because otherwise you can't read the unsigned transactions that you need to sign. You can't understand, you can't show them to your user. And PSPT already contains metadata such as names and XPubs, binary encoded compactly for free, in the sense that it's included to the standard. And my proposal, which is on GitHub, on Blockchain Commons Research GitHub repository, is pretty much just PSPT, but with fields that are specific to descriptors. So it has a field for the output descriptor itself without keys, and it has what is in PSPT called a map.
Still wearing shorts because you have no clean pants? Huh?
Sorry?
Your microphone is open,
Got to
Sean.
get over this laundry block that you have. I know. Oh shit, is my mic on? Oh, I'm sorry.
No problem. So yeah, so PSPT already, it has the concept of key value mappings and a map, which is a set of these mappings. So it already has a standard for a representation for binary XPubs, and it has a representation for numbers and so on. And that's enough for my proposal to specify the descriptor, which is text, and a key map or a map for each key, which includes its binary encoding and its name, and that's probably it. And you can of course include metadata such as the name and the birthday or the birth block of your descriptor. I wrote a from scratch codec in Go, and when I say from scratch, it's I can just link it here so people can actually click on it. When I say from scratch, it's both the PSPT decode and encode and my extension to it, output descriptor representation. I call it CARD, compact output descriptors, and it's all in 300 lines. So that's just to give an idea of, and it's complete. Not the PSPT, but that there's enough decode and encode so you can represent, you can both read and write output descriptors in this proposal. So that's, I think that's a short description of the differences. If you have any questions of how is PSPT actually structured, you can ask it, but I don't think it's that relevant about it after this. So the next problem I have is probably bigger than the CBOR versus PSPT. It's more of a process, and we could say it's an overlapping of the issue of the duplication of crypto output and crypto account and so on, in the sense that how do we avoid not doing the same, getting into the same situation as we are the crypto output. And again, from my perspective, for crypto output, we don't really use crypto account as much, but I see a lot of readers. I see a lot of software and devices support crypto output as for reading, but I don't know of any writers except for Sparrow and ourselves, and we only use it because Sparrow uses it. And
CTool, the iOS app that we produce, does it as well, even though we don't consider it to be a third-party app. CTool outputs crypto outputs and crypto accounts.
Yeah. Okay. And because I come from the Bitcoin perspective, my question is, again, this is more the process, it's not a format. Why wasn't crypto output BIBed? What is the difference between the BIP and the new Bitcoin proposals, not Bitcoin, sorry, blockchain commons proposal system. Why don't you use just the BIP? Again, maybe that's a larger question, but it's also part of this issue of how do we avoid this schism or this non-standardization issue 3 years down. And again, and this is more, the last thing is maybe a little bit controversial in that if you assume that a BIP is a good way to get more widespread support among wallets, I would like to know or ask myself, that's how I started this proposal on my own, is what would be more likely to be BIPed, a specification based on CBOR or a specification based on PSPT. And again, I have my reply to that, but I will just give the question out so you can make up your mind in that sense. If that's I guess that's if you don't consider that important, of course that's a different thing. But I think that's a very important question, whether it could be BIPed. And again, and finally, what will it take to make whatever comes next a successful standard? And these are my suggestions, again from the Bitcoin perspective. The almost tautology is that simple is more likely to be accepted, and in my mind, PSPT is much simpler to read and write than CBOR. I think we should learn from the crypto output BCR process. I think we're already doing that with the BCPs and moving forward to version 1, version 2, or whatever. I think it's important to propose whatever comes next as a BIP. So if it's the envelopes, then it should be proposed as a BIP. And I'd like to see, like Craig from Sparrow, before we move to something else, also our own format, if we can call it that. I would like to see some more buy-in from wallet developers before assuming that whatever format is standard. So a good question for wallet developers would be, what would make you switch? Not to reading this new format, because most wallets would read most anything, because it's not that difficult to add more formats into it. But what would make you switch to it as an export format, so we can move towards a world where there are fewer things you need to be able to understand wallet descriptors.
So yeah, I have a few responses, but I'd like to give other people present, say Craig, Ken, or anybody else who wants to ask questions or respond to your presentation. Thank you, by the way, E, for your presentation. Before I kind of give my response, which, as you know, we've been discussing on GitHub. So, questions?
Look, I do think the point that if the goal here is to create standards, and I use that term loosely, that are adopted by wallet developers, then certainly in the Bitcoin world, my experience has been that you're not going to get too much success until things are a BIP. And once they are a BIP, it's a very different situation. My BIP 329 is one that is for labels and wallets. And, I could have just gone off and built my own thing, like many other wallet developers did. But I found that, once it becomes a BIP, it really gets a mark of it's reached a certain level, and there is much greater acceptance and interest from other wallet developers to build on it. So I can certainly vouch for that personally, having experienced it myself.
Yeah, I think we certainly agree with the importance of BIPs. Our BCR and now BCP, they're really intended to be a pre-standard track where we can work with the community, see which things actually have buy-in, and advance them through that. And at the point where they have buy-in, the whole point of BCP is that it is something that has been adopted and we feel like should be pushed into a standard. So kind of DCBOR and envelope were our first endeavors where we actually pushed them onto the standardization track. But our intent has always been that we expect we will advance some of ours to BIPs as well.
Any other questions for E or statements?
Are any comments on anyone who's done any work on CBOR and constrained environments? Ken, did you have any thoughts on that with Passport?
Yeah, I just wanted to see, I know, E, one of the things you had said was, you didn't want to have an external reliance on a specification as complex as CBOR. I wonder if there's a way forward to say, in the BIP, say something like, okay, well, this is based on CBOR. However, if you're in a resource constrained environment, here's everything you need to know. Here are the numbers you need to put in to make this envelope. Here are the numbers you need to like right now, building a PSPT is just the same, right? It's just a matter of what number do you put in that spot that it's CBOR versus what number do you put in that spot that makes it a PSPT. So if we could make a specification as a BIP that was internally complete enough to implement, if that was all you wanted, I wonder if that would satisfy that requirement. But then if you already have a CBOR encoder because you're doing more than just that, you could just take advantage of it and not have to write any of that CBOR parsing code yourself. Just rely on your existing library.
I would love that. That would be perfect for me. Assuming that, and I think that's important to us all, that whatever specification comes through the BIP process. So if you can have it accepted as a BIP and it's self-describing, and you can write a note, if you have a compliant CBOR decoder encoder library, then you can pretty much skip all this. I would be perfectly happy. What I want to notice is, because Wolf and I have been discussing this on GitHub, is that there's a subtle difference between being able to write a format. And I agree with Wolf, it's probably very easy to write a from scratch enveloped descriptor writer, but to create a reader minimal or from scratch or self-sufficient without many dependencies, you need to be able to read all of the possible, or at least ignore the fields that you don't know.
Yeah,
So
I was just going to say, like, in your case, for example, if you're receiving this file in CHammer, you could just say, "Oh, I don't understand this," and reject it. Right?
And actually, that's quite easy to do with CBOR. I will say, I'll get more into that when I speak. But yeah, CBOR actually it makes it really easy to skip what you don't understand.
Want to jump into that, Wolf?
Okay.
And the only other thing perhaps is I'd love for, and this is for this is based on we want compact descriptors, so this is a little bit more specialized, but I'd love to have in the envelope standard to have binary or compressed XPubs. So instead of having them in the descriptor text itself, I'd like to have them separate somehow, very similar to my proposal and to the wallet policies BIP I also linked to.
I think Christopher was asking for that too, if I recall.
Are you okay though with this text-based encoding of the descriptor itself, as far as the size?
Yeah. No. Well, yes and no. We're not okay with it in the sense that we want it as compact as possible. But as I started to say, and Wolf was also mentioning, I don't think it's realistic to expect a specification that can binary encode all descriptors, because we'll have to have these mirror specifications for every text, because the text, for better or worse, the text format is the one that is very widespread. So each and every time they add something new, for example, Craig's change address proposal, where you don't need to have two different descriptors, you can have a variation that specifies both the change addresses and the receive addresses, or a mini script or whatever comes. It's going to be a maintenance burden. It's possible, but it's going to be a maintenance burden to specify those. And that's the direction and that's the primary reason I don't like the crypto output format, because I like its compactness, but I don't like that everything has to be mirrored to the descriptor world. So I think both the envelopes and my own proposal is that's the best compromise we can do. It's not as compact,
and that is one of our motivations for also backing away from the crypto output specifications, because the output descriptor world is still fluid and moving forward, and we have to track it closely.
Yeah, that makes sense. But I would also say, like, if it does change, if something changes, you're not gonna recognize the text version of that descriptor anyway, right? Like, it's gonna have stuff in there that you don't know how to parse.
Yeah, absolutely. I think the problem is that it'll have to be specified and tested and so on, where in a specification, so you have to extend the specification every time it comes. So it's a specification problem, not as much.
And the way forward with that would be to be really tight with whoever's. If this becomes a standard and it's binary, you just have to say, like, if this BIP is going to be approved, you have to have already, if there's a BIP that extends the descriptor format, you'd have to work with with the team working on, blockchain comments, let's say that was what was going forward.
Yes, and
to coordinate and say,
yeah,
oh, this is the tag that you have to use. Yeah, for sure, for sure.
Yeah.
But like it gets you the compactness that we hopefully all would prefer.
Yeah, well, again, that would be a compact CBOR or a PSPT or whatever representation would be ours, such as us from Seedhammer's perfect world. But I don't think it's realistic to require every output descriptor developer or new pips to also have to specify their binary representation. If that is appropriate and accepted by the Bitcoin community, then we're all very, very happy. But so it's more it's a compromise more than the ideal form.
Yeah, so I mean, I would rather shoot for the moon and fail, maybe. But maybe there's a way to do both. Can we have it Wolf in a version 2 that it can be like string or this other encoding, or is it just like
I think you'll run into the decoder problem again. If you have an OR, you'll have every decoder need to support both the text and the binary version.
Yeah, that's true.
And also, if there's, obviously, if we continue advancing our Gordian envelope based output descriptor format, then we have 3 formats to deal with, and that's obviously something I think we'd all like to avoid.
Right.
So
one true format. Right.
Well, we already have version 1 and probably version 2, but yeah,
yes,
I mean, or again, if we decide that we just want to go back to crypto output and skip the Gordian envelope, that's also a possible decision this community can make.
And shooting for the moon is appropriate when you develop software, but I don't think it's appropriate necessarily for specifications, because specifications are meant to be widely accepted and implemented. And the more you have in that specification, and again, that's one of my critiques of CBOR, which may be moot, is that the less chance you get of people actually adopting it.
And of course, one of the biggest shortcomings of crypto output is, as has been mentioned, not just the fact that we're squatting on CBOR tags we're not likely to get. We're also, not able to track very well the moving target that is output descriptors. If I may, go into a little bit more about, the conversation Ian and I have been having, and kind of, my rationale for why I think that, Gordian envelope is actually quite viable for this purpose, even in constrained environments. I'd like to share my screen here. Let me do that here. That's interesting. I seem to have lost the ability to share. Am I still a co-host? Shannon,
Are you still what?
am I still a co-host on this?
You should be. Yeah.
Okay, that's interesting. All right. Well, all right. This will work. All right. So this is a part of the GitHub thread that Ian and I have been having on. This is a research repo issue 135. If you want to follow along, but this is his response to mine. But I'm going to cover what I said here, because one of the things I wanted to demonstrate is that despite the fact that CBOR has a certain amount of complexity to it, then DCBOR restricts that complexity. And then envelope is built on that, but it's designed to be very compact. It's designed to make simple things simple and hard things possible. And that's one of the guiding principles we had when we did this. I can make this a little bit bigger. Oops, is that still gonna work? So I get making things bigger on the fly here. Okay, so all right, so I gave a demonstration where a minimal output descriptor with no name or note metadata, but just the ISA assertion output descriptor here. Here's the actual textual output descriptor, which is, as we've seen before, I've truncated the binary here. But as you can see, it's basically only got 12 bytes of overhead on it. And depending on the other features you want to support, the overhead would go up a bit, and also the complexity of parsing and writing would go up a bit. And I'll discuss that a little bit. But if you knew that you had a constrained environment, which was going to receive envelopes, which just had the minimum, which was just the is output descriptor. I mean, obviously, if it knew it was going to receive just an output descriptor, you could just send the string. But let's assume that you want to have a forward-looking thing where you're sending and receiving envelopes, and you want to be able to use that as your standard. That maybe later on you can support metadata, or you can support other advancements in the kinds of things people want to do with metadata around output descriptors. Okay, so but this is like the minimum starting point, and I wanted to demonstrate that it's not hard at all to even read and write this without any knowledge of CBOR or envelope. And so he, and I asserted that, and he challenged me to say how I do that. And this is what I came up with. Okay, so if you know nothing about CBOR or envelope, then you have header bytes and you have suffix bytes, and you have a variable int for a length, and then you have the UTF-8 string of the output descriptor. That's it. You don't even need to worry about what these mean or what these mean. You can check them to make sure that they are in fact what you expect, and that these values have to either be 68, 78, or 79. Other than that, this is not followed by any additional length bytes. This is followed by 1. This is followed by 2. There's also variants for 4 and 8, but we're not practically going to support those, so those don't need to be part of the spec. So in this case, as you can see, the text has 78, which is a 1 byte length, and 9A, which is 154. So this string has 154 bytes. And if it's for some reason less than 24 bytes, then you just it would be hex 60, and you add the immediate length to that to get whatever hex value for that 1 byte. So and that's all valid CBOR, and it's a valid envelope, which basically means that once you have this, any CBOR parser can decode this, and you can just parse it as CBOR. Any envelope decoder can parse this and understand this is an assertion with known values for ISA. Remember, I have said that that's 1, an output descriptor, which is 507. These are not CBOR tags. These are known values, which is a namespace we control, not IANA, not CBOR working group. So and so we can assign low number tags to whatever we like. We can, eventually I would hope that if we advance this to an RFC, then something like IANA would take that registry over, because again, we do have a vision for this. But and I said, that's it. No mention of envelope or CBOR at all. Any code that implements the above spec can read a Gordian envelope with a minimal output descriptor structure, not including name, note, or other metadata. Now, what would be required to skip past those things, or to say, for example, validate the ISA output descriptor and skip past this? Well, because this is a map. This is a map with, remember, a map is a set of key value pairs, so it has one element. So this is key value, ISA output descriptor. And this is an array of 2 elements. This is the leaf array, which is tag 24, which is just encoded CBOR. Inside that is text, a string of figure length. This array for each assertion gains 1 more member, and it has to be a map, A1. Then it's going to have probably a single byte for if we're using known values for this. In which case it's going to be a single varint. This is an example of varint. And it's going to have some amount of length information after it, which again, if you figure out how to just parse a length in CBOR, then you can skip that many bytes ahead. So you can iterate through this on the parsing side, trying to find the map that has the key value of 01 and the value of this to verify that's an output descriptor, and then you can skip past all the other assertions. So it's actually really simple. On the writing side, if you want to write assertions, it's a bit more complex because you need to essentially follow the Gordian envelope rules, take the SHA-256 hash of this and sort them by hash order. And those are all very deterministic. And the reason for that is so that the assertions aren't randomly ordered. This is the deterministic idea that both CBOR and envelope are deterministic, that if you have certain assertions with certain semantics, and they will always converge on the same binary output. Just merely parsing CBOR in a constrained environment, just parsing this as CBOR, you don't have to have an envelope parser. You can use a CBOR parser. And outputting, you don't have to have an envelope writer. You can have a minimal CBOR writer as long as you have a SHA-256 algorithm at hand. Then you can determine the proper order of the assertions. I wanted to deliberately show the minimal case, how simple this is, but also that it's future proof. Now, I would point out that that PSBT is a de novo spec. It's not based on any other previous existing binary format. It doesn't have its own independent spec of how you would encode various things in PSBT. Therefore, even though PSBT itself is a BIP, its binary encoding format as such is not. And whereas this is based on both the CBOR as well as envelope, which are documented, which are both IETF internet drafts, which basically means they're potentially standards track. And honestly, I would hope that if PSBT, if the PSBT spec had been written with the knowledge of CBOR, it might have ended up as CBOR as well. Because it really is, I think, a better format for general binary encoding. They are obviously trying to solve a particular problem, and they created a de novo way of doing that. We have it now, and we're going to be continuing to use it. But that doesn't mean I think we have to. Personally, I would feel uncomfortable adding another spec based on PSBT without a separate document, which actually gives a future to that kind of general format. And my general feeling is, why do that when we already have something that's very solid and this simple to read, write, and parse? And then let's see. I think E basically said. He said, I certainly believe a minimal decoder for envelope description is feasible from scratch. And yeah, I actually think that the decoder for this is easily as small, and even skipping over unknown assertions, I think only adds a few lines of code actually. A writer is not very hard as long as you have a sort algorithm and a SHA-256 algorithm handy. Let's see. Name, note, or other metadata is key. Will a minimal decoder be able to successfully extract the descriptor from every envelope, including those metadata? Yeah, I just answered that. Anyway, that's my basic approach to this, and I'm happy to answer questions or address other concerns.
Will the structure use the same binary structure if there are more fields, for example? That's what I referred to when I said leaving out the metadata is at least an issue. So if you add, let's say, name and birthday and all these other structure to, as you say, it's extendable, and it is, but it's only extendable if the minimal decoders will be able to read it.
Right. Well, a minimal decoder that can skip over what it doesn't know and only parse what it does is actually still very minimal. It's not, it depends on how you're defining minimal. If you need to fully validate something, if you, for example, as DCBOR or as a valid envelope or something, then that's you're going to want more code to do that. If you decide that that's already happened before you receive the structure, and you trust it, then you can parse it in full faith that it's compliant, and then if you run into anything that doesn't comply, you can just reject it. As having broken the contract.
So I guess my concern reduces to if a bit can be written that specifies how this format looks like for output descriptors, and that specification just happens to be a subset of the much larger CBOR or DCBOR, then I'm perfectly happy with it. Do you think that's possible?
What I've effectively just demonstrated? I hope. That was my intention.
I don't think you did, because, for example, 82, just to take an example from your example, is the map with two elements. So if I add a name and a birth block, for example, then that 82 will be different. Is that correct?
So
sure.
Okay, right, yeah. So right, exactly. So if you're going to support, for example, skipping past ones you don't know, then you have to treat 82 as it's in the range. In fact, let me show you this. So this is basically a slide which demonstrates the 1 byte header of CBOR. And so the 82, if you look up 82, that is a 2-element array. And so if you expect something in the range of array, then you know how many, if you find an array at all, it's what's called a node in envelope, which is a subject followed by a series of assertions. And you can always assume that in an output descriptor as an envelope, it's always going to be an array. It's always going to be a node with at least one assertion that is an assertion. So you can expect something in this range. It's not going to be 0. That would be legal. It's not going to be 1 because it's going to have the output descriptor. It's going to be 2 or greater. If you see 3 or 4, then, even if you see 1, you basically take the count from here. And then you basically iterate through those structures. Now, because CBOR is self-identifying, if you have, a very simple, you can use a jump table for this. It's only 1 byte. Then you essentially know how much data you have to skip. and essentially known values in envelope are not tagged CBOR. They are literally an integer. They're the only bare integer in an envelope is a known value. So you don't have to do anything special. You come across an integer in these spaces, you know it's a known value. You just know it. There's no other way of encoding an envelope. And so if you come across these things, this range in an envelope, it's a known value. It has to be. Now, if it's like a leaf that's tagged 24, which has an integer in it, well, that's just an integer of some kind, and you have to know from context what it means. But the concept of an envelope, a bare integer is always a known value. But basically what CBOR does, because if you know this table, and again, it's actually a very straight, if you have a very low code to this range here from 0 to 1B is a varint. Okay, it basically has, this is all 1 byte, 2 bytes, 3 bytes, 5 bytes, 9 bytes.
Okay, but I'm going to stop you. Can we at least agree that an existent proof of you showing one encoding of one particular descriptor is not the same as a specification that says how to write a decoder that can understand everything?
Yeah, well, okay, it depends what you mean by everything. Okay, so for example,
everything that is, of course, specific to output descriptors. It doesn't have to understand everything.
Well, for example, let's say you wanted to support compressed output descriptors. Okay, Gordian envelope has a built-in compression standard based on deflate. You can compress any envelope based on deflate, and because everything inside an envelope is an envelope, you can take that text string, that UTF-8 text string, and re-encode it, transform it into a compressed envelope. In which case it's understood to be compressed. It's the exact same, it has the exact same hash in an envelope tree, hash tree, but it's essentially the same thing compressed. And if you come across that, well, then you need to obviously support the deflate algorithm. But you still don't need to support all of envelope, everything envelope can do. You don't need to support cryptography. You don't need to support elision. You just need to support, I'm parsing this. I'm parsing the CBOR stream, and here's this tag, which basically means I have come across this compressed thing. Here's the header, and I'm going to use the deflate algorithm to reinflate the contents. And there's my text string.
Yeah, can we agree that every feature that you add to envelopes or like this, like compression, has to be supported by every output descriptor decoder?
I would say that's trivially true for any standard that purports to encode output descriptors, whether it's the text string itself or whether it's anything around it that purports to do metadata, like your standard or your proposal or mine. I think that's trivially true, and I'm not sure what the point in debating it is.
The point is that I don't have compression as my proposal.
But you've discussed it already, which basically means you might want to support it. So then you have to discuss how you would support it.
I took it from your proposal. You have compressed envelopes, which is a feature. But from the point of view of specification and a person writing a decoder, it's actually not a bug, but it's a maintenance burden that you have to add this new thing.
Only if we specify that it's supported. So that's the thing is, okay, well, I think what you're laboring under the misconception that if you support part of envelope, you have to support it all. And that is absolutely not true.
Yeah. Can I just say something?
Yes, please.
Yeah, I think you're totally right. Like, we can restrict the subset of CBOR and envelope that is in this specification. So, you can easily, like, if you want to support compression, whether it's PSBT or CBOR, you're going to have to write code for that. If we don't want to support compression, then we don't have to, include that in the specification, and nobody has to write decoders for it.
Right. As a matter of fact, I've already published specifications in our research repo. For example, attachments, which I've discussed in our last meeting. Which, if you read that, and I'll put the link in the chat here. If you read that, you'll see that it says what must and what may or may not actually be in an envelope in this case, and it basically doesn't allow anything to be compressed. It only allows certain assertions, which have to be in certain order because of the nature of envelopes. It recommends certain things for certain strings or whatever, but that's because those things are kind of open to possible further standardization or whatever. But the point is, if you look at what a attachment envelope may have in it, it's not anything, and you can't compress stuff and you can't encrypt stuff in an attachment and so on. It has to be what it is. Now, inside an attachment is the vendor-defined CBOR, and that can be anything, but that's basically up to the vendor. They can put another envelope inside there. They can put anything they want. That's not what the attachment is. A way of making discoverable attachments on other envelopes, and that's its purpose. So to be discoverable, it has to be something that can't be, it has to be understandable to third-party writers who haven't encountered it before. And the purpose is to give attribution and some idea of discovering and recognizing envelopes. So, but as you see, if you read the spec, it's a very constrained specification itself. And there's no reason why every single, I mean, in fact, that's what I'm doing is every single spec you see written based on envelope there's certain envelope extensions like cryptography, which basically expand what an envelope can contain, but there's many specifications which are only purely restrictive. DCBOR itself is a restrictive specification on top of CBOR. CBOR allows you to encode many things that DCBOR does not allow. So actually a DCBOR codec by definition can be smaller, more compact, faster, tighter than a CBOR
I love
codec.
DCBOR. DCBOR is a great idea. You specify minimal encoding, so that's much closer to what.
And the same design principles apply to envelope as well.
Yeah, well, let's just say if you can present a specification that is bibbable, so it contains a complete description based on CBOR, of course, or TCBOR, or whatever you want to say, then I'll be more than happy. So you can, from that specification, write a decoder from scratch. It doesn't have to be 300 line. I'm not saying it has to be very small. It just has to be complete in the sense that it's practical to implement from scratch.
Right. And there's things you can do too, other restrictions, like if, for example, in the map, right, you have to say how many entries are in the map. If you don't want to write all of the code for every possible integer encoding, you could say, okay, well, in this specification, the map has to have less than whatever.
Right, you can have 1, 2, or 3 entries.
Byte.
If it's 1 entry, it has to be the ISA. If it's 2 entries or 3 entries, no name could be added. Yeah, and the spec can contain those things. Yeah.
Or it still could be combinations, right? Like, but you just know that you're not going to have like 400, entries in the map. You're restricted to whatever you can encode with, a simpler encoding, like 8.1, 8.2, 8.3, 8.4, 8.5.
Yeah, exactly. And I think that one of the things that E has expressed concern about is, for example, if you look at my current Gordian envelope Bitcoin out descriptor, it basically assumes, the existence of envelope and the existence of DCBOR. It kind of incorporates them by reference, because it doesn't talk about the binary encoding of is an output descriptor. It basically knows that, that's what this is. And when you talk about an output descriptor and its assertions, the actual binary encoding of this kind of falls out of that. And of course, our tooling lets you take any envelope and output its annotated binary description. But there's not much more to say about it than this in terms of a high level description. If you want to create, but for example, like JSON, you don't need to describe what JSON is to define a JSON document. And the same is true here. So the question is, does this have to be something that is so divorced from CBOR and envelope that they can't even mention it? And what would be the purpose of that? Because there's plenty of things based on.
Of course you can mention it. Of course you can mention it. My worry is the decode side. It's almost only the decode side. I will be able to figure out, or anyone can figure out, how to encode something because they know what they need to encode. They need the name, and that's it. It's the decode side where I can't be sure. Just because, for example, your example on GitHub, I can't be sure that just because I successfully passed that and a few variations, I can't be sure that, say, Passport Foundations don't present me something that uses that has more fields as
the thing is if they comply with my specification, this specification on the screen right now, they can't. Okay, it may include a has name assertion. It may include a note assertion. All right, it must include it is an output description. There's nothing else allowed. Okay,
but so how is it extensible? How is it then extensible?
We extend the specification. We write another document that is run through the community, which basically says this version of the specification adds another assertion. Or we say, for example, we support attachments. So vendors, and so once you know what an attachment is, you also know how to skip past it. This doesn't mention attachments because, again, I was trying to keep it simple, but we could also make it so that it supports attachments, in which case it's extendable by vendors.
But also, if you write your code such that it recognizes ISA, has name, and note, but nothing else, and skips the other things, even if it is extended, your parser should still work.
Exactly, and because CBOR is self-describing,
I'm happy.
Yeah, because CBOR is self-describing. Everything has length values in it, so even if you don't know what it is, you know how to skip it.
Yeah.
You know, full CBOR parser will parse everything, validate it, and then hand you back a symbolic representation of the CBOR document. But if you just want a streaming CBOR decoder, very simple, that just parses each byte and you know, uses a state machine to you know, say what's expected, what comes next, and so on. Then yeah, a very simple specific purpose parser can be very small. And it doesn't matter that CBOR, it doesn't matter that it's DCBOR, it doesn't matter it's envelope. It can be very small. So and I can give you more worked examples if you need further proof of that. But you know,
no.
Yeah.
My point is, and I hope that I'm a little worried that this is a misunderstanding. Examples is like, it's like saying this number is say even or something. You have to, it's sort of decode. The decoding issue is sort of a mathematical proof in the sense that.
Well, what I mean is, by example, I also mean we could write some reference code that actually, you know, you know, that write, you know, in say Rust or whatever, that is totally standalone, doesn't use the rest of our Rust stack, and essentially encodes and decodes, you know, and ignores fields it doesn't understand. That's an afternoon's worth of work for me, you know.
I was just going to say, like, you could have that by the end of today, probably.
Probably, yeah. And I actually believe it'd be less than 300 lines of code. Again, like I say, in Rust is a bit more verbose. So the boilerplate might add some more.
Will it support the same as my proposal? So names, birth, block, and compressed XPubs.
So again, it also depends on. So I would need to study yours. If I want to match yours feature by feature, I would have to. What I can say is that it could definitely support ISA, has name, note. You know, if you want to date, then we have to decide what date format we're going to use. DCBOR has a date.
No, not a date.
Just a block number. Just a block number, integer. Simple integer.
Yeah. So I mean, it depends, but the answer is yes. It should be pretty easy to add any of this metadata that you want. If I just came up with, if I spent the afternoon and did something that is the equivalent of this, it's probably less than an hour worth of work to add every single, you know, to add a new metadata field that it understands.
Okay, and that could be written as a specification in a future bit.
Yeah, well, I mean, if you can write code, then you can write a specification from the code. I think in code anyway. Yeah. So
I'd rather have the specification, but code is also will work for me.
Well, I would do both.
The only thing with a block number is it's a wide range, right? So you'd have to have the different integer encodings supported, being able to decode the different integer encodings.
Right. Well, again, if you're using CBOR variants, then you just basically, you can, you know, go up to 8 bytes worth of space, right? So, you know.
No, I'm just saying, like if you were really trying to divorce this from CBOR, you would have to define that in the specification as well, like that you for values under, you know, 24, whatever it is, it's this, you know, you just like define all what the integer encoding is in the document versus reference out to CBOR.
Yeah, exactly. And honestly, again, if you just want you're just talking about parser, right? It doesn't need to necessarily write these things. You're more concerned about reading them. Is that correct?
Also writing, but I know writing is a simple problem.
Yeah. I mean, obviously, you know, with envelopes, if you're writing metadata, then you need to do that little dance with the hashing and sorting. But again, that's not a big deal, even in a constrained environment. You know, I do feel like, yeah, this is, you know, I understand that this is not as familiar as, say, you know, PSPT is, because we've all worked with PSPT. Our stack, you know, for example, when we parse the text format, or when we parse PSPTs, where I think we're using, well, one of the open source libraries, I can't remember which one off the top of my head that we're using, but yeah, I mean, we're using other libraries to do that for us, to parse PSPTs, to parse output descriptors. Actually, we wrote our own output descriptor parser, but and that's a problem for us if we ever have to, you know, for Swift at least. But my point being that you know, it's having I understand this is less familiar, and our goal is to support the Bitcoin community in both understanding why we think this is important, as well as you know, kind of lowering barriers to adoption. And that's what this conversation is about. Obviously, if you still have deep reservations about this, then, you know, we'd like to allay this, because, you know, you're one of our customers, essentially. You're one of our community, and we want to be of value to the community.
Yeah, let's talk about moving forward. So I'm not against CBOR, and I can see the idea of having a specification that can both be self-contained but also happens to match the CBOR encoding. And of course mention that, so you can use a library if you want, and you can write it more or less from scratch if you want. So if Blockchain Commons is willing to propose something that will end up as a bit, then I'm more than happy. And I don't know about Ken and Craig, yeah. So
agreed.
So it have to,
Totally
I'm not
agree.
married to my proposal. I'm just I made it so I wouldn't seem only criticizing envelopes. I also to have a constructive proof of what could be done and what I think should be included, such as the compressed XPubs, the made it name, and so on. But if it ends up being something, a specification not too long, and it just happens to be formatted in a way that's compatible with envelopes, then I'm perfectly happy, more than happy.
So is block number the only missing thing? Like if we were to have a version of the code that could, skip additional fields that could be added in the future, is block number the only thing missing from Wolf's example?
Well, I think
compressed XPubs as well. Names,
compressed
the actual name, compressed XPubs in a similar format as the PSBT. Doesn't have to be the same, but where you don't encode it as base 58.
Do you have a test vector that you can send me for that, E? Something that shows the actual kind of, okay, here's how this is represented in, say, either your format or in other places where compressed XPubs are used. Is that it? You just pasted it to chat?
No.
Okay, so this is the Bitcoin repo.
Yeah, so this is the Bit wallet. This is what I used as my example for extracting XPubs, the keys out of the wallet descriptor, but it doesn't specify serialization. As far as serialization, my format, it's this is my example code here.
Right. Yeah.
And
this is written in Go, correct?
Yeah.
Yeah.
You can run it here, and you get something binary out. It's let's see if I can see it in binary. So it actually encodes. Yeah, it encodes the descriptor in what I see is in wallet policies format. That's the top, and then on that line, that's the descriptor with references to keys, and then there's the array of keys underneath, and each key consists of the fingerprint, the path, and the key itself, decoded from base 58. That's the representation I chose. And
I'm curious, assuming that we can use this format for the textual form of output descriptors, is there any reason to, even as part of our proposal, to support uncompressed descriptors as well? Or should we say that this should always be put into the form where these references here,
that's fine. Yeah, that's exactly what I propose. I propose to
so that we don't need to support more than one.
Yes, exactly. I disallow XPubs in the descriptor in my proposal because I think there should be only one way to represent keys.
Yeah, I concur with that, and there's no reason why. See, and I would say here's the thing: if we're going as far as to support textual output descriptors, and then a format that has some structure after, in addition to it, which is the keys. Obviously, that's not going to be backwards compatible with BCR 2020-10 and 15. There's no reason why, at that point, we even have to use. The reason why we chose envelope is because we're just going with the textual output descriptor. We want to wrap it, and that's metadata. There's no reason why we cannot define another low-level CBOR struct with a tag nobody has ever seen before, nobody's going to hassle us about, that we can actually put inside the CBOR output, because again, we have the tags we're squatting on. Okay, so and and they basically identify UR output descriptor and UR crypto account, or UR crypto, anyway, the point is we could define another CBOR structure that is not based on envelope, that you could still put inside an envelope if you want additional metadata. But if all you want is a name, a descriptor in text, which is this format and has references to an array of keys after it, obviously it might not be deterministic, because unless you have, say, what order your keys come in, it's not deterministic anymore. They could be in any order. Well, actually, I guess they have to be in the order of the references. So that's not true.
Yeah.
So as they're defined here in order, well, again, I guess if you could say 0, 0, 2 and skip 1, then okay. So, but in any case, the order would still be deterministic. It wouldn't matter how you reference them here. All right. So yeah, I'm just thinking this through in real time here. But my point being that we could define just a CBOR structure, and CBOR, you still have to parse variants, because obviously you need length, but it would have a is this what you mean by compressed keys? Because this isn't really what I think of as compression. It's basically just transferring something to binary, decoding to binary.
That's what I mean. That's not. It's compact. I prefer to call it compact. It's just not using base 58.
I hate base 58 for most purposes, especially when we're trying to do data on the wire or at rest. So yeah, I agree with that. So my point is, taking what you have here as thinking, rather than based it on PSVT's binary, you could base it on DCBOR without even basing it on envelope. That could still be put into an envelope, there's, again, because CBOR supports envelope, is CBOR and supports CBOR.
Sure.
And we could kind of have the best of both worlds. I think that
and we avoid the sharp 256 field ordering, which is it's not a big deal, but it is a deal.
Well, yeah, you would avoid that, and so I think that if we and honestly, this is even easier than doing it with envelope in some ways, because envelope is designed to be very extensible, to have all these other features capable, and yet, it can be minimally. But CBOR, I think we all agree, can be even more minimal. It's just not going to support those other things envelope describes. And with CBOR, there are ways of skipping things you don't know, but obviously if you're not prepared for them, then you're going to throw an error. But if you're prepared for stuff you don't know, then you can skip past it. And so even when you have like a CBOR, which can, for example, this is an array, and it has, or even a map where this is like an integer for name, and then a CBOR string, an integer for a descriptor, and these can be our own. This is totally local to this object, as is with our other CBOR data. And then an integer for this, and so this is a map, a CBOR map, and these can technically come in any order, so you have to be prepared for them, and there could also be unknown. There could also be unknown fields. Sure. There could be duplicate fields, there could be omitted fields that you have to check for, and that all makes a validating parser more complex. But it also depends on how much you trust what the input you're being given. Envelope tends to validate these things automatically, but then you still need to validate which assertions are present and stuff like that. So any serialization format is going to have a lot of the same issues. But CBOR by itself, and there are very tiny CBOR implementations, and you could still implement a bespoke parser for this if you really, really wanted to and didn't want to use a micro CBOR implementation. I mean, a micro CBOR implementation wouldn't support floating point values, wouldn't support a number of other things that CBOR supports. Exactly. And but I mean, we can define a CBOR structure that
in our case, just to be very practical, rewriting Go, and I'm not familiar with Go implementation that maps to tiny CBOR or whatever was linked to. And of course, you can interface it with Go, but then you have two compilers, two build tools, build chains. So I would actually, in practice, probably implement this from scratch, whatever you come up with.
Right. Yeah, and by the way, DCBOR basically says that if you use map keys have to be in order, and it defines the order. So I mean, again, whether or not you're validating, you may not care, but certainly when you're writing, it's very easy to know what order the keys should come in and write them in that order.
Exactly. The more restrictions, the better. Not duplicate keys, this particular order by integer or whatever. Right. The more restrictions, the better it is.
Yes, absolutely.
All right.
Okay, well, I think that is certainly moving the conversation forward. Any other comments from other people?
Yeah, I think we got some great notes from that. So, I want to be respectful of everyone's time, and I know it is getting toward the 2 hour. So I am thinking that we might want to just skip through the presentation we were going to do. Do you have any problems with that, Wolf?
Yeah, no, there's not. I mean, basically, the announcement is that our Rust stack has gotten to the point where we now have a command line tool that I will I'll in a moment here I will post the link to that. And if you have Rust installed, then it's just cargo install bc-envelope CLI, and that will install our whole stack. And if you look in the repo, yeah, it's is it BC on? Okay, I'll look for it anyway. Maybe Shannon, you can find the URL for that and post that to while I talk. But yeah, so so I'm not going to demo it. We've done previous demos of the Swift CLI tool, and even though the syntax is slightly different, the semantics are all the same. And the repo has documents in it that show both our walkthroughs of how to use the tool. And it doesn't necessarily teach you envelope from scratch, but it does point you towards everything you need to know, and it pretty much walks you through building up very complex structures on a command line. And then yeah, that's it. So I think we can forego the demo, and if there's a demand for a demo, that I can do a demo next time. Of course, next time we also expect to have our distributed share server up and running, at least in minimal form. Which will also be based on a Rust stack. It will be a web server based on the Rust Warp web server framework, and our backend will be MariaDB. And then we have some code we wrote in Swift that is basically there you see tinyurl.com/example store that is kind of shows how we're using trust at first use. So you don't need to create a prior account. Obviously, there's security concerns about denial of service and stuff like that at some point we'll have to address. But essentially, this is the idea: is you can anonymously store data that you've encrypted any way you want. And yes, it has to be Gordian envelope, but again, that's not a big deal if you understand our Rust stack and our kind of ethos regarding this. But the idea being that what's inside the envelope doesn't have to be known. It's just a block. It's just a blob, essentially. And so, but the idea is our tool stack will support using SSKR to shard data like seeds or keys or whatever, and then find a number of these servers that are out there running, and store shares among them in a way that is retrievable, and then also fallback methods so that you can have another way of retrieving your shares if you lose your public key, which you use to access these depositories. And we're calling them depositories, not repositories. The reason is repositories tend to be about active version control, whereas depositories are something you just put something for safekeeping, which is the goal here. So I'm happy to answer any quick questions regarding that, but there'll be a lot more to show next month.
Yeah, so this is really a fulfillment of the CSR work that we've been doing all year, building on SSKR and envelope. Okay, so and just we wrote a little bit about what the goals are of CSR. We want to create an interoperable ecosystem of share servers, and we really want to give users the choice. We saw Ledger Recover come out this year, and it didn't give users the choice. It locks them into the equivalent of share servers that require your customer work, and so it violates our principles of privacy and self-sufficiency. And so we're trying to create something, have been trying to create something that is very different and goes with our Gordian principles, which do include privacy. So the CSR depository is going to be our first example of that. And hopefully
we'll also be supporting things like TorGap and things like that as well.
Yeah. And Bitmark, who isn't here today, has already done kind of their version of a CSR server, which they used on a previous version of Autonomy. So we're hoping to create an ecosystem here where we can start exchanging shares. I hold yours, you hold mine, and thus everyone has better backups and more resilience. So that's our goal there. The only other thing I had on the listing was that Christopher has been doing work all year on what he calls musings from a trust architect, which are kind of stepping back and saying, what are some of our more architectural designs that we're doing that are leading us to create a lot of these individual specifications. And he most recently wrote one on self-sovereign computing, which looked kind of at how can you be in control of your own digital destiny on the seas of the internet, as it were. He looked at some design patterns for how we can minimize data that we're storing. And he also wrote a nice introduction to Snore, which is really coming into increased interest, not just because of Taproot over at Bitcoin, but also because the Zcash Foundation just released a version called ZF Frost, which we think we may be using in the future for things like VSS, verifiable secret sharing, which will allow us to check that people have shares. So those are always all on our Blockchain Commons website under our posts. But we also recently moved his Life with Alacrity blog over to Minimal Mistakes to make it cleaner and more up to date. And it now has all of his musings there. So that's a really easy place to find them all. So that's much of what we've been doing. And that is Chris, who will be back next time.
Yeah, thank you all for joining us, and thank you for your comments, your input. I feel like this has been a very productive conversation. I hope you feel the same. Please send me your other thoughts, or Shannon or Christopher, and you know, I expect we'll have a lot to talk about next month.
Yeah, Signal is great.
Just to wrap up, are you thinking to make a proposal around what you were just describing? As far as the
well, obviously,
based?
unless somebody has, wants to offer reasons why that shouldn't happen. I mean, I'm not sure I'm going to prioritize that yet with my work on the server, on the CSR server. But depending on the perceived urgency about this from people like Craig and E and things like that, I might take a diversion and take a couple days and get some code, get a spec up based on that, and so we can peruse it before next month. Obviously, we're looking to the community to help set our priorities as well, particularly our sponsors. So become a sponsor. That's definitely on my mind now. And sometimes when something's on my mind, I have a hard time not doing it.
Yeah, I think
Wolf,
Yep, go ahead.
Yeah, sorry, I was just going to say, I think the situation that we find ourselves in now is we have a deprecated standard, again in air quotes, and no clear what is the next thing, right? And I think that, right. As you say, this meeting has moved us forward, but I think we do need, what we don't want to be in is in a situation where we have users coming to us and saying, why are you still producing a deprecated standard on something that my funds depend on? I don't think that's a situation we want to be in for long.
Which is why we're trying to make it very clear that our BCRs are not standards, and even though we put running code with them, and these are for community review, and that's what we are, the community who is reviewing it. And I don't know how to emphasize that more. We are going to, basically have the BCP repository. Some of our things like UR, like envelope and so on are kind of ready to be raised to that level. Others like output descriptor, I'm not sure are quite ready to be raised to that level yet, because we don't have, obviously we want backwards compatibility, but we also want, something more forward looking. Maybe Gordian envelope with that is it. But if somebody implemented that today and then got mad at me for deprecating it later, I would kind of say, why did you do that?
But it sounded from like what we discussed earlier that updating crypto output with a version 2, which might be the thing that we're talking about here, might be the way to both push it forward and make users feel like we are not stepping away from it. And it's just a question of, hey, are you using version 1, version 2? So that, part of this is just making users feel okay. And that might be a good way to do that. Does that seem accurate, Craig?
Yeah, no, I wasn't trying to, make a point around, going back to whether things are standards or not. I was more just talking to the prioritization of, we are where we are, and let's try and move to a better place. That's all that I was saying.
Absolutely, yeah. I mean, that's
and we just need
what we're all striving for here.
those talks internal about what the prioritization is, but we're certainly hearing that. We need to have the talks with Chris about what the prioritization is. But we're certainly hearing from the community, this is a priority.
And if you have any, deeper concerns that are unspoken, if anybody watches this video later and has strong feelings about it, please reach out to us. Please reach out to myself, Shannon, or Christopher. We're all easily contactable. And please let us know what your thoughts are. This is those of us present are only a small slice of the community we're trying to serve, which also includes our sponsors and many other people who aren't here. So please participate.
Yeah, thank you for all the great feedback today.
One small thing. Would it make sense to mark those BCRs a little bit clearer? Because so far it seems like Craig and myself and probably also other people have misunderstood. So not only mark the BCPs, but somehow, I don't know.
I think probably we should put a disclaimer at the beginning of our BCRs that they're a research document, that they're for review only. In fact, I think we have said that in a lot of places. We certainly say it in our code repos and our reference repos.
I think the question here may be if deprecated is the right word for it. I think
not just that. Also, the new, for example, the envelope proposal that Wolf made about descriptors, and I understand he would be sorry if people started using that as a standard. But to me, that was not clear. We were about to say, okay, what's the next standard? And looked at envelopes as an implementer, CTAM. And we don't want to be in that situation.
Yeah, well, one of the nice things about defining a CBOR structure, assuming especially if it's conformant to DCBOR, which is easy because it's a subset of CBOR, is that it's automatically compatible with anything you do with envelopes in the future. So it's not an envelope, but it can be a leaf of an envelope, and so it's immediately compatible with the envelope ecosystem. You do have to parse it as CBOR rather than as an envelope with assertions and all that, but it's baked in. So yeah.
But we feel like the people who use the research specs, they're our partners. There are research partners who are testing things out. Early adopters would be, I think, a fair description of it. We aren't to the standard level. We need to test things out and work with you, the community. So among other things, you can tell us this doesn't work because, when we get up to the level that 2 people are using it, then we want to put it to the level where it's slightly less changeable. And then we want to get it as a real spec, but it's definitely a spectrum. We want you to work with us on it. But we also want you to work with us as early adopters and understand that there may be changes, but on the other hand, that shouldn't invalidate what you've already done.
Yeah, I like the term research partners better than even early adopters, because adopters implies, releasing something into the wild. And while you are totally at liberty to do that, it's not necessarily advisable until we all have a kind of agreed that, yes, this is the way we're moving. And, honestly, there are certain things we've done at this point, like the UR specification, which is based on byte words specification, the DCBOR, the core specification for Gordian envelope, which is now an internet draft, DCBOR is too. Those things are really solid at this point, at least as solid as we can make them without then taking them to a standards body and then getting to like a BIP or an RFC. But that is what we plan to do. And it's just that, until we get to that point, and that's what we want to do with BCPs, is advance something as, okay, we think this is going to go to the next level kind of thing, or could.
And if you look at the BCP page, we actually have a
BCRs can conflict with each other. They could even express conflicting opinions. We might want to, call that out even more explicitly in our headers for our BCRs.
Yeah, but if you look
at our research
at the BCP page, we actually define a couple of states for things. And one of those states is mature, a BCP draft that's been fully matured and that we feel is ready for the next step. So as opposed to a work item. So even within this, we're working to say, hey, what are the things that we feel like are solid? And so I think what Wolf just defined, the byte words, URs, envelope, we'd put those into the mature category where we think they're solid, but there's always what happens when we put them to a standards organization.
Right. Well, as we learned, definitely when we submitted DCBOR and Gordian envelope to the CBOR working group, and they came out much stronger for that, but they were breaking changes.
Yeah. So one of our tasks going forward is to figure out which BCRs need to move to BCPs and to figure out which ones are still work items that we might, be working with the community to change, and which things we feel like are mature and unmoving. So that's definitely an action item on our part. We've just defined these different levels, and we need to move things over to them.
I would just close on for my end anyway. I think, Wolf, if you can take a day or so and it doesn't conflict with the other stuff you're doing, I think it would be really worthwhile to do the pseudocode example and explore that alternate CBOR.
And that feedback is super important to us because obviously, I think you are a sponsor, right, Ken?
We are, yeah.
Yeah, and that matters coming from anybody, but it matters even more coming from a sponsor. So that's that's the kind of feedback we need and want. And yeah, if there's other eyes here or a general consensus that I should get that done, then that makes it a very high priority for me, and I know Christopher would agree.
Mm-hmm.
Cool.
Well, we really appreciate all the feedback. I feel like this is one of the meetings that we've got the best feedback, and so it's been a terrific meeting, and I'd love to see more like this.
Absolutely. Tell your friends. let's make this a real community effort, and whether it's online during these meetings or in other venues. But yeah, let's keep building this. I'm excited because Blockchain Commons has a vision of not having to have everybody reinvent the wheel. And be able to have a lot of interoperability that respects people's privacy and sovereignty. Those are all great values. I think we all share them, and we need to come together to do certain things in that area while each having our own secret sauce in our businesses. And that's awesome. Let's work together on those parts that we really ought to work together for the benefit of everybody.
Yeah. Thank you.
Thanks so much for all the work on this, Wolf. Appreciate it.
Yeah.
Thanks a lot.
E, thanks for bringing us up as well and getting the concept moved forward.
Perfect.
Thank you, everybody. All right. See you next time.
Cheers.
Yeah.
Thanks, everyone. Ciao.
All right. Bye, Shannon.